Deeper learning is having a student always have the wonder of life. I think that they should be able to look at any content and always have those inquisitive questions. How does this work? Why does this work? What if I change something? How can I make an impact on what this content means in my life? The class lesson today, the students were investigating physics principles of looking at Earth's interior. So students were looking at what happened in the earthquake in Afar, which is a region in Ethiopia. The students have been investigating things that they've observed through data, through documents, in order to kind of come up with an evaluation process of what they think is happening based on the evidence.
All right, so of course, I love to just put up there what our Massachusetts frameworks are and what standards we're going to hit today to the best of our ability. Student-friendly voice, what do you have for me, Joy?
It's basically saying that by the end of the lesson, we should be able to explain how Earth's system interacts and how those certain interactions shape the Earth's surface today.
Love that. Go for it.
So for HSESS 1-5, I think it's talking about how we should be able to figure out how plate tectonics move and change in the past and current as of right now.
Yeah, I love that. So you guys all put them in your own words. Is that easier to grasp? All right, in your own student-friendly voice, what are we doing today?
We're gonna be studying how seismic waves affect different systems of the Earth and how they're even created.
We have our criteria for success. Can I have a volunteer read it real quick? Go for it, Aslan.
Communicate predictions from the model test to their peers. Students will sketch established team norms and designated roles to complete prototype model tests and graph analysis.
You got it. So today, you're going to have the ability to go through different stations. I'm going to give you about 8 minutes. What I provided for you today is kind of a menu. So you can go through your menu. You can look at what we are doing today, kind of like a navigation, checking for that understanding where we need to be. Thinking back to our last lesson on investigations, what did we figure out about what causes earthquakes? How does this explanation allow us to understand how volcanic eruptions occur?
You could say that the friction causes tension in between the near the volcano, which is what makes it grow.
Wait, which one comes before first, the seismic waves?
Yeah, because I think that's what causes it, or maybe the tension causes the waves. Actually, I don't know.
And it's usually divergent when the lava from the mantle spews out.
So let's go into our responses. Who would like to share their response?
To answer the first question, I said we figured out that most earthquakes happen when the tectonic plates spread apart, also meaning a divergent boundary occurs.
All right, so you told me tectonic plates did what?
They split apart from each other.
So kind of in this after image, right? This model. And what else?
That's it. I just said it means like it's a divergent boundary in place.
Okay, so it means divergent boundary and plates. Who else? Thank you, Joy.
I think that the two questions are related and that tectonic plates cause tension, which is like what makes the seismic waves. And because of the tension happening, volcanoes near the tension can cause a spark in the eruption of the volcanic eruption.
Okay, so you combine them both as well. From you guys answering the questions, how many people feel they have kind of a foundation of what's going on? Thumbs up. Thumbs to the side if you're like, I don't know, Ms. Cardillo, I know Andy said some words I just don't know yet, or maybe how we kind of put all those vocabulary terms together, and we still need a little bit of work to go. Yes? And then thumbs down if you're like, I am thoroughly lost about how earthquakes actually happen. We kind of have a handle, right? We kind of have a temperature, and that's where we're at right now. So let's talk about this navigation for Afar. Where did it all start from? How we started this process, right? Where we have been.
Earthquakes and volcanoes in East Africa did not appear to be along an established plate boundary. What ideas could explain where the focus came from to cause earthquakes, volcano eruption, and breaking in the Afar region?
Let's share out on this one. So what ideas can we come up with that can explain this?
I say it's from the mantle, the force on the mantle that give some pressure in the center can cause the earthquake and volcanic eruption.
Okay, so you're talking about those pressure from the mantle that's causing that earthquake. Nice job, Lud. What do you have for me, Jalen?
I feel like the forces could have came from like pressure like build up and like it caused like not the plates to move but like the surface to like crack.
Ooh, okay, so we got some new terms happening here. Pressure, and now cracking.
Don't know how we would find out where the source of all these forces are coming from, right?
Definitely think you're right. It has something to do with convection currents. But I think to add on to that, we know that these tectonic plates, they are not they're not smooth. They are rigid. It's like trying to move two puzzle pieces together that do not fit.
We could look at like graphs to see where the seismic waves are traveling.
Yeah.
Or we could like, I don't know.
All right, we'll come back. But you can definitely look at articles, right? What else?
We came up with looking below Earth's surface, and we were gonna compare the data from earthquakes that happened on the plate boundaries, and we would compare it with what happened what happened at the afar region, because we would look at the similarities and differences, and that'll probably explain why it was happening.
Yeah.
Can analyze past seismic waves.
Yeah, so we can look at past data charts, we can look at documents, I heard simulations, things under the ground. Nice job, everyone. So can everyone look at that? Why do scientists explore Earth's interior? You are going to go through each of the different stations, answer the questions, the guiding questions that it's asking you.
And then I like how you're tying it here to Arctic Circle. Why do you think that's important?
Like back in 1970, right? We didn't have like modernized material, so I'm like wondering how like they made a big machine to like dig into the deepest hole in the Arctic Circle, like in the Arctic area.
Yeah, especially.
It's made out of ice though.
Yeah.
So I'm guessing like it's easier than digging the one in the U.S. soil.
Yeah.
Because it's mostly made out of rocks. Compared to Arctic, it's made out of ice, so I think ice is like much more easier to dig.
Yeah. I think this is a great question, right? Because you brought up a couple of things. You're talking about time, and then you're talking about the progression of technology, right? How important was it for them to dig in 1970 versus 2025?
Yeah.
And what is the impact of that discovery? What do you think they found now?
Yeah.
And if we throw in global warming, right? What do you think the Earth's interior would expose now?
Yeah.
Right?
We are creating our own Earth.
P waves, they cannot travel through a solid.
In fact, those are the primary waves.
Yeah, primary waves.
They can travel to everything.
Yeah.
Only S wave, they can only travel to solid. They cannot travel to liquid and gas.
Yeah.
What do you think the beads are representing?
The magma.
You got it. So what do you think would happen if I grabbed this and I started to shake it in a horizontal position? What type of wave am I creating?
Oscillation.
So
I would say
S wave. S wave. Sorry.
I don't know, you tell me.
S wave.
And what happens if I start lifting it up and shaking it?
Never mind. It's P wave.
What wave is that?
That's an S wave for sure.
All right. So what happens when I put a structure that I construct on top of these? What's actually
It dies.
happening?
It dies.
It just
I don't know. You tell me. Start building.
All right.
This is fun. We must use 12 toothpicks in our construction. I have 4 right now.
Wow.
1, 2.
You tell me. What do you think?
For S waves, it's 3 kilometers over S, which I think is over seconds. And then for this one, for P waves, it's 11 kilometers over S.
So what do you think you need to do next?
Test the data points,
Okay. So where are the data points?
the 2 I just said.
Okay, good luck. You're welcome.
My house is so
And is there any questions you're still left with? You need more information on the model. Can you sketch what does the model look like? What is one thing that you learned and one question you still have? Can you write that response? In our notebook? You can write it on your notebooks. You can write there, write it right on the peer deck. What is one thing you still have regarding this lesson? And if anyone would like to share.
P-waves can travel through different types of matter compared to S-waves, but they can only travel through the solid. And
Okay.
P-waves can travel through water and stuff like that.
Ah, so you brought in the fact it can travel through water. Nice job, both of you. Enjoy, thank you. Anyone else would like to tell us one thing they learned today? Or if you wanted to draw your response, that's cool. One question you still have about the learning. Heavy, go for it.
I just wanted to add on with Azim. Even though the P waves can only travel like through solids and the S waves can travel through things like liquid, but like liquids, the P waves travel through solid rock faster than S waves.
Also travel through. So you're talking now mediums, how it's solid, right? And it's traveling through. I like that you're adding that on. Subduct to go beneath, right? All right, so you had a lot of observations that you guys noted that was happening there, right, with those vocabulary terms. Nice job, everyone.
Short-term outcomes of deeper learning is that you start seeing enrichment and learning happening. Students are happily engaged in the learning. They know that it's a space for them to utilize any of the skills that is a focal point of the lesson. The long-term effect is that they're able to embody these skills and bring that to their new settings. Deeper learning is having the foundation and supports in place for students to take their learning to the next level.